Question 7 is coming from trigonometry, but assure that this is equal to this. So we solve this the same way we do fractions. So the LCM is actually going to be this one here. We multiply the two, then this multiplies with this, and then this multiplies with that, okay? So I'm going to begin with the left-hand side. Let me just write left-hand side. It's going to be equal to, so this times this, we shall have cosine of theta plus 2 sine of theta multiplying with sine of theta plus 2 cosine of theta. And then this times this one here, there is a minus. So sine of theta minus 2 cosine of theta. This one multiplies with cos of theta minus 2 sine of theta. Then the whole of this, we divide it by the product of these two. So that is cosine of theta minus 2 sine of theta, then times cos of theta plus 2 sine of theta. Now we just multiply cos times this sine here. We shall get cos of theta sine theta. Then again, cos here times 2 cos of theta, that one becomes 2 cos squared theta. Then this times this, that will be 2 sine squared theta. And then this times this, that will be 2 sine theta cos theta. Now we come to this one here. Already there is a minus here. So sine theta times this one here, that will be sine theta cos theta. And then sine theta and this one here, that will be a minus 2 sine squared theta. Then this and this, minus 2 cos squared theta. And then this and this, that will be a plus 4 cos theta sine theta. Then down here, this is just a difference of 2 squares, okay? Because this is the same as this is that. So I just say cos squared theta, then minus, then we square this one here. That will be 4, then sine squared theta. Then, or if you want, you can expand it all together, but this is what you are going to end up with. Next, now we simplify. Cos theta, sine theta, then plus this one here, that will be 3. So 3 sine theta cos theta. And then here, we can have 2 into cos squared theta plus sine squared theta. And you know that this one is equal to 1. So that means the whole thing here is a 2. So 2 times the 1, not so? Then we come to this one here. We have this and this, that one will become a 5. So there is a minus here. So we shall have minus 5 sine theta cos theta. Then this one here will be a minus 2, okay? That one will be, remember there is a minus, so it turns everything here positive. So it will be plus 2. Then again, sine squared theta plus cos squared theta. Then down here, everything has to be written in terms of cos. So that means we shall have cos squared theta, then minus 4. Sine squared theta is the same as 1 minus cos squared theta. Now let us simplify. And there is a mistake here, pardon me. This is 4. I was supposed to have 2 sine theta times 2 cos theta. That one is a 4. Okay? Or is a 4. So meaning when I get this plus this, it will be a 5. So therefore, I have to change this one to 5. Now you can see that this part here is going to go with that one. Okay, and then this one here is a 2 plus a 2. That one gives us a 4. So we shall have a 4 here. And then down here we have cos squared theta minus 4 when I open the brackets, then plus 4 cos squared theta. So 4 plus 1, that one gives us a 5. So meaning our answer is 4 out of 5 cos squared theta minus 4. That is exactly what they have told us to prove up. Part B, hence solve that equation. So we begin from where we have stopped. This whole thing here is 4 out of 5 cos squared theta minus 4. Then you equate to the 5. Now you cross multiply. This will be 4, then 25 cos squared theta minus 20. And then when I try to bring this one this side, or I take this one this side, it will add up. Okay, then we shall have a 24. So in other words, 25 cos squared theta is equal to 24. So meaning our cosine of theta is going to be, first of all, 24 divided by the 25. Then you take the square root. And when you take the square root, you take plus or minus. So meaning cosine of theta is going to be the square root of 24 over 25. We shall also have this same thing, but with a negative. Okay? So with a negative. Now here, cosine is going to be the arc cos of this one here. The same thing we shall have also this other side, but we are taking the arc cos of a negative. Okay, so this one is a positive. Of course, it will give us the angle in the first quadrant. Okay, remember, when I draw this circle here, I always use this circle. We see that cosine is positive in the first quadrant and also in the fourth quadrant, but it is negative in the second quadrant and the third quadrant where we see sine and tan. So this is 0. What is our domain? Is 0 to 180 degrees. So we are moving like this anti-clockwise, because when we move anti-clockwise, the angles are positive. So this is 90 degrees. This is 180. Of course, this will be 270. And then coming back here, this will be 360. So if I have an angle theta here, and then I also project it down here, opposite angles are equal, same to this one here, and also here, theta. So to move from here up to here, it will be the whole of this, which is 180, then minus this theta here. So meaning this one will be 180 minus theta to get the angle in the second quadrant. Here it is 180 plus theta, because you are moving like this. This is 180, then plus the theta there. See that? Then this will be 360 minus the theta. But we are interested here and here. Now, when we take the arc cos of this one, we are going to get the answer there in the first quadrant. So the next answer where cos is positive is here in the fourth quadrant, but it is out of our range, which is given us from 0 to 180. So we shall just pick one value. So arc cos of the square root of 24 out of 25. You need to be careful. You have to check the mode of your calculator. So if the domain given is in degrees, make sure that your calculator is in degrees. If it is in radians, change your calculator to radians. Okay. So this one gives us 11.5. Okay, this is 11.5 degrees. Now, when I put a negative, the calculator will give me the obtuse angle straight away. So I'll just come here, put a negative. That will be 168.5. Okay, 168.5. So I'll write my answer smartly here as 11.5 degrees and 168.5 degrees. That is that these answers to one decimal place. Now, also, if you don't, because you might get one where you're having tan or sine, and yet the answers you get for those, they are going to be negatives. So this one, it is the same angle you get when you ignore this negative, right? Now you go to the quadrants where cosine is negative. So we see it here and here. That implies that I will say 180 minus that acute angle I get when I ignore the negative. You see that? So when we say 180 minus the 11.5, this is the one that gives you the 168.5.